Okay, picture this. You are in a coding interview and the interviewer asks you to find two numbers in an array that add up to a target. Your first thought, nested loops, right? But then you remember, wait, that's gonna be O of n square. And suddenly you are sweating. Hello world class coder, welcome to BackToCoding. I am Milind Amrutkar and today I'm gonna show you the technique that will make you go, why didn't I learn this earlier? The two pointers pattern. Trust me, once you get this, you will start seeing opportunities to use it everywhere. So here's the thing. We have all been there, you know that feeling when you write nested loops and your code works but it's just slow, like embarrassingly slow. Let me tell you a quick story. Imagine you are at a huge library and you need to find two books that together cost exactly $50. Now you could check every single book with every other book. That's thousands of combinations. Or you could be smart about it. What if you had a friend helping you? You start from the cheapest books, they start from the most expensive, and you meet somewhere in the middle. That's two pointers. Instead of one person doing all the work multiple times, you have got two pointers working together efficiently. Alright, let's break this down in the simplest way possible. You know, when you are reading a book and you use two fingers to mark different pages, that's literally what we are doing in code. Two pointers is just using two variables to track positions in an array. That's it, no magic, no complex theory, just two markers moving through your data. Now these pointers can move in different ways, and this is where it gets interesting. First, they can start from opposite ends and move toward each other. I like to think of this as two people in a long hallway walking toward each other. Second, they can both start from the beginning but move at different speeds. This is like having a tortoise and a hare, one's slow, one's fast, but they are going the same direction. And third, there is this cool variation called sliding window, where the pointers maintain a specific distance, kind of like looking through a window frame that slides across a view. The beauty? Instead of checking everything multiple times, you usually solve the problem in just one pass. Okay, enough theory. Let me show you why this is so cool with actual code. Say we have the sorted array 1, 3, 5, 7, 9 and 11 and we want to find two numbers that add up to 10. First, let me show you what not to do, the nested loop approach. See all those nested loops? That's checking every possible pair. With 1000 elements, that's almost 500,000 checks. Now watch the two pointers magic. Let me trace through this with our array 1, 3, 5, 7, 9, 11 and target as 10. Step 1. Left is 0, value is 1, right is 5 and value is 11. Their sum is 1 plus 11 equals 12. Too big. Move right pointer left. Step 2. Left is 0, value is 1, right is 4, value is 9. Sum is 1 plus 9 equals 10. Perfect. Return 0, 4. Two steps. That's it. Instead of checking 15 pairs, we found it in two moves. That's the power of two pointers. Let's do another classic, checking if a string is a palindrome. You know, like race car or madam reads the same forwards and backwards. Here's the two pointers approach. Let me show you how this works with race car. Step 1. We compare left R with right R and we found a match. Step 2. Compare A with A, again a match. Step 3. Compare C with C, again a match. Step 4. Compare E with E, pointers meet in middle. So the result, it's a palindrome. We only checked half the string, super efficient. Now something different, the fast and slow pointer pattern. Given a sorted array with duplicates, remove them in place. This is where we use pointers moving at different speeds. Think of it like this. Slow is a writer with a pen, fast is a reader with glasses. The reader scans ahead and whenever they find something new and different, they tell the writer, hey, write this down. Let's trace through 1, 1, 2, 2, 3 as our nums array. Initially, slow equals 0 at value 1. Fast is 1, nums of 1 equals 1, same as nums of 0 equals 1. So we skip it. Fast is 2, nums of 2 is equal to 2, different from nums of 0 equals 1. So we write 2 at position 1. Fast equals 3, which is nums of 3 equals 2, same as nums of 1 equals 2. So we skip it. Fast equals 4, nums of 4 equals 3, different from nums of 1 equals 2. So we write 3 at position 2. The result is 1, 2, 3 with length 3. We overrode duplicates as we went. Alright, before we wrap up, here's my cheat sheet for 2 pointers success. When to use it? Array is sorted, 2 pointers alert. Finding pairs, triplets, 2 pointers. Palindrome mentioned, 2 pointers. In place operation, 2 pointers. Here's the universal pattern. Most 2 pointers problems follow this template. One pro tip, always ask yourself, why am I moving this pointer? If you can answer that, you have got it. So there you have it, 2 pointers decoded with real code. The time complexity drops from O of n square to O of n. Space stays at O of 1 and you look like a coding genius. If this finally helped you get 2 pointers, smash that like button. Subscribe for more algorithmic patterns broken down simply and drop a comment. Which pattern should I decode next? Until next time, keep coding like the champion you already are and keep watching Back to Coding.